So, ladies and gentlemen of both sexes and genders. So I try to be as much politically correct as possible. So now we will switch to more earthly affairs and more empirical affairs, and starting our second morning session. So this will be big Ugrophonic accent in these papers, and more traditional one approach, an empirical approach. So I would like to ask Jana Limbo to speak about dental pathologies in Estonian materials. Jana, please.
Hello, my name is Jana Limbo and I'm from Tallinn University from Institute of History. And I have been studied teeth for quite a long time, and actually idea for this research came from my latest research, detailed research from caries, and I decided that same skeleton series should be closely looked at, and the presentations became true. I don't know how to start, but I want to add that most of us know that dental pathology can describe not only general or dental health, but also social status, diet habits, and so on. And now I turn next slide. Okay. And in my research, I included very many series from Estonia, and time-lapse was from migration period to early modern times. And totally about 400 individuals were included, and I don't know how many teeth, about 6,500 more than that. So I tried this pointer. Okay. Of course, I watched together some skeletal samples. For example, prehistoric end from northeast Estonia, Jouga and Pada, they have very similar occurrences of dental pathologies, and I just same time, and I just put them together. Also, skeleton series from Western Island I put together, and the other ones with Lepna is migration period. Pärnu is small town from the beginning of early times. Taxi also the same as Pärnu, only the village cemetery. And the latest one was Hargla. It's also village from the beginning of modern times. And it is important, and in current study I recorded most often dental pathologies. I recorded these pathologies per individual, and dental caries is easy. Only complication is recording if the individual have or not. And it is clear if individual have 4 teeth and one of them is caries, you can say the individual has caries. But what about case if individual has non-cariogenic 3 teeth? I excluded such cases, and only 4 molars were represented in individual, I encountered this person. Pre-mortem tooth loss, it's easy to record. I included only such cases where tooth socket was already closed. Tooth calculus is very difficult to record because it occurs in different teeth, in different amounts. And in this study, I included all calculus cases. In my opinion, this gave the most clear picture. I show you. Reduction of alveolar bone in molar region. Very easy. How to say? I used the Bravel method and included such persons who had degree 2 or 3 as affected persons. Abscess in tips of root of teeth. The only confusion is if some cases were excluded because I analyzed individuals by naked eye. It is important to show you my previous studies. I think I haven't talked about this, at least in this audience. And I studied very, very finely caries occurrence in this skeletal series. And I got very, very, very nice results. As you can see, the incidence of caries is increasing. And it's now not matter if you look at molars or all teeth together. This is also very important. Actually, you can look at molars and you got quite similar picture. Also, I got that severity of caries increased over time. Also very nice. And also the primary location of caries was very clearly different, and the degrees in neck area in approximate sites between teeth and degrees of severe caries where primary location was not able to establish. Nice picture. The strong caries into pulp increased gradually from migration period. Just nice picture. Situation got complicated. If I counted only, if I count the caries per individual. As you can see, if you count per tooth, the results are very clear, but actually no differences between groups if I look at individual level. Although it is said that more informative is to count per individual all pathologies. So just put to show you that over the time, these are European groups, the occurrence of caries have grown, but in my opinion, differences between groups are even bigger than differences between different times. So if you put all observed series together in Europe, you get nice picture. But if you try to compare very specific populations, you probably got very strange results. And pre-mortem tooth loss. Again, usually due to far developed pathology, and main cause is usually caries. And I only encountered such cases where tooth socket was closed already, and same confusing results. Actually, even per tooth socket with pre-mortem tooth loss doesn't show anything. And in individual level, it also, in my opinion, doesn't show much. And I already told that severe caries and tooth loss are closely connected, and usually tooth loss is a result of severe caries. And although it is not possible to show some increase over the time, I found a very clear connection between tooth loss and caries in individual level. In per tooth level, I didn't find such connection. Actually, you can say that if population have more caries, it should have more tooth losses also. Dental calculus, just for them who doesn't know how it looks. And the most usual places are in surfaces of molars and incisors, and dental calculus forms near the salivary glands because it needs alkaline environment. This mineralization process, I hope plaque mineralizes in alkaline environment. And I put this dental calculus, tooth loss and caries on the same figure, and it is said that caries and calculus should have opposite occurrence in the same population. I would say my result in some way show this, because formation of caries needs acid environment. But we all know that caries as well, dental calculus occur in the same individual. But they usually don't occur, not usually, they don't occur in the same teeth. So you can find in a population that has more dental calculus, they have little bit less caries. Reduction of alveolar bone in molar region. It is not possible to say exact reason of this pathology, but the main cause is said to be periodontis disease, and periodontis diseases are usually connected to plaque and poor mineralized plaque or dental calculus. I'm sorry, this green line is not marked here, and I saw the clear connection between dental calculus and reduction of alveolar bone, and this gave me idea to test if in the same individual these pathologies co-occur. And actually I found quite good correlation, although it is not very big, but it is strong, statistically significant. So probably individuals who have calculus don't have often reduction of the bone or periodontal disease in the living person. Oh, this is a very awful picture. But I just wanted to show these abscesses. I don't know if you can see them. I see hardly. This is not abscess. This is foramen mentale. And actually, this abscess starts when infection reaches to the pulp cavity and forces such pus collection under the root. Okay, I don't want to talk about I have no time. And also, dental caries is considered to cause dental abscesses, and I found connection again in population level, and it seems that the individual level also is clear connection between these two. An individual who has severe caries has probably also abscesses. But now the main result, conclusion. All skeleton series are here, it's time lapse, and actually it is said that you can describe the diet of a diseased by dental pathologists. It seems that if you calculate severity and location of caries, you can say something. And we have studied many of these series also by trace element, by zoological and by botanic, and we know at least some of them what these people were eating. And actually this analysis does not support the idea that dental pathologies or pathologies of mouth can describe diet. I don't know. I should research this further, study this further, but these are preliminary results, and that's all I can say. If you look at teeth level, and not the occurrence, but how and where this lesion is formed, you can say something. But if you just take this standard analysis, I would say you can't say anything. Every population have all these pathologies, and it seems quite same level. Of course, you can analyze if the caries is very high, the calculus is low as supposed to be, but that's all I can say. Thank you.
Thank you, Jana. So seems there are already questions coming.
Thank you. How about the age of the individuals? Was it similar between?
Yeah, I know all pathologies are connected to age. And I tested also age, and the later populations have more older individuals than the earlier ones. This may affect, but I looked at teeth level, and there was no connection with age.
Some more questions?
Did you see any correlation between these tooth diseases and any other pathological lesions in the skeleton?
I haven't studied it.
Okay, because we know cases of, I think, trypanomatosis, which is usually manifests in teeth, but there are also lesions that might be caused by the same pathogen across the skull, for example.
In this case, my idea was to find some dietary changes.
Okay.
I didn't find that.
So, discussion seems to be rather vivid. Some more questions? No, well, I would say, Jana, so please don't be such a skeptical with your results interpretation. So it's evident. Well, you get some trends. And
I have to study further. I know that.
And well, just interpretation sometimes is not always so straightforward.
Yeah.
So because,
It's
well,
true.
if it would be so straightforward and so easy to interpret, so how to say, all low-hanging fruits are already collected. So now it's.
I just want to say you can't look with standard results and say something about occurrence of pathologies, say you what the person was eating. It's not so clear.
Well, of course, you cannot say who preferred beef or who preferred pork. Yeah, from that. Well, but it's because there is multiple connection of various factors, and finally, well, you have some definite trends. Many things are interconnected, not only nutrition but also diets, dietary habits, other activities, well, and so on. Well, but anyway.
I think the genetical background is also very, very important.
Oh, everybody just know how to say once blames genetics.
Yeah, blame. But structure of email and also the company in your mouth, the small company in your mouth, it is genetically hereditary.
Okay. Well, thank you, Jana.
Thank you.
And so now we will go to even more smaller fragments. So to cremation. So Riley Limbo, Riley Alme, sorry.
Okay.
Also from the same institute.
Hope it works. I have this one. Hello. My name is Riley. Does it work?
Yes.
Okay. And I have to find my presentation. And I will discuss of Iron Age cremation graves in Estonia. I have to say I started this because of curiosity. In 1997, I was asked to excavate cremation graves at Saaremaa Island in Estonia. And when we spent there a whole month, me and archaeologist Liina Maldre were very surprised because we found only few human bones. And very often we found the full skeletons of dogs or birds. So I became curious, and after that I had two projects where I worked with cremation graves. The first one was conducted with archaeologist Mati Mandel. And the next one here in southern Estonia was in cooperation with archaeologist Mare Aun. I investigated 8 stone graves from 5 to 13th centuries. And the number of studied bone units was nearly 1,600. And in southeastern Estonia, there are different burial constructions. There are sand barrows piled up, but they are from the same time period. And I also studied there one flat ground cemetery, one tunnel grave, and as there were the bone assemblages were bigger, the number of studied bone units is smaller. But I put my main focus in this presentation on stone graves of Maidla and sandbarrow cemeteries at Rõsna, because they are the most representative graves. They are totally excavated, and the others are such small graves that, or cemeteries that are only partially excavated. But I use this data for comparison of these smaller cemeteries. And research questions, if you start working with archaeologists, it always starts at how many people were buried and biological age and sex, and what is the size of the community. But I somehow thought that I had to record better this data, and I started to do, for example, measuring bone fragments. The longest bone fragment in one bone unit, the biggest granular fragment in bone unit, to get some data. And I also started to register color. And the final question, of course, is always that if you are studying many graves, are there temporal changes in burial practice or cultural differences, such kind of questions. There are methods. I already told you about how I did this recorded fragmentation. Color of remains I discuss in the light of these works. Age, sex, and population size, the methods are here. But I also did the number of burial a little bit differently as usual. As usually has done. I say that the minimum number of burials is what we get from recurrent bone fragments. I counted many of them, but of course the Pars Petrosa of Os Temporale is the best one. And the plausible number also I did somewhat differently. I didn't use this most likely model. I expected that the human bodies were cremated with craniums, with heads. So I counted the number of cranial fragments, and if I found in this burial area, for example, one terminal bone fragment, I say that in this area was one burial, because in stone graves, the scattered cremation is prevailing. And it's very difficult to locate the actual burial there. I also dated cremations in the dating laboratory of Helsinki University. And I used to calculate the life expectancy, I used the Bouquet and Massey model, which is based on juvenility indices. There is a scheme of Maidla stone graves. Here you can see how there is the first stone grave, and it's supposed to be from 5th and 6th centuries, according to archaeologist Matti Mandel. And the later grave, second grave, is from 10th to 13th century. It's actually at the moment the biggest cremation grave studied osteologically in Estonia. It looks like that. It's not a very good picture, but it's from archive. It's stone grave, it's stone fillings. There are some data. It was excavated in 1980s. As you saw from a picture, this is a stone construction with stone filling. And there were present cremations as well as inhumations. And according to archaeologists, these inhumations were from end of from the 12th to 13th century, which means that it's the ending time of this cemetery use. And as I told you, cremated bones are all scattered, and also the parasites were inside the burial area. The earlier grave, Maidla first grave, the number of subadults was quite representative, 40%, or 8 burials belonged to children. And And the opposite, Maidla second grave, there were 42 cremations, and I could determine only 2 children among them. But a lot of inhumation of children in Vans was present. Actually, I wanted to show this picture. We did separate these works. Archaeologist Manti Mandel was working on his research, and I was working with this my cremations. And when we put together the book, I actually saw that the spearheads are following the pattern of cremation burials. So it might be that these spearheads are marking the cremation graves. Radiocarbon dates of these burial sites I made because I wanted to specify the usage of the graves, at what time they were used. Actually, they fit quite well what the first grave seems to be a little bit older. The second important set was the sand-barrow cemeteries in southeastern Estonia. This is the culture of long barrows. And it was also excavated in 1980s. It contains long and rounded barrows, piled of sand. And one cemetery consists of several barrows, and there only cremation burials were found. And there was no found of parasites in the burial area. And of course, in these sand barrows, the burials were much bigger and much better preserved. Here is a scheme of Rõsnasaare first barrow cemetery. It consisted of 10 sand barrows. There is a photo of sand long barrow. They can be sometimes 50 meters long or even more. And here are the results of my osteological first result. It's a minimum number, plausible number, and the percent of the adult burials in graves. They are between 35 and 40%. Also dated the graves, and it gave. It says the datings are saying to me that they are contemporaneous. These 3 burial places. They are from the 4th to 6th century. And then I used to make just small calculations of newborn life expectancy and community size. And this is, of course, a model because I used this dating data as usage time of the one burial place. So I got this data that actually mostly one family used one burial site. And here I once more emphasize the difference in cremation burials because the number in long barrow culture of children, number of children is much bigger among cremations. In Maidla earlier grave, cremation burial was quite common for children, but Maidla second grave, very few child cremations were found. And also I found from their occasional inhumations of infants much later periods. I also made some notes on coloration, fragmentation, and percentage of determined bone units. And I found out that in Maidla first grave, the temperature was around 600 degrees. In Maidla second, it was much higher. And here, very often, the sooty bones were buried. And that means that the bone fragments were buried with biodebris and charcoal. And I also registered dark and black fragments, and I found them to be 10% in 10% of bone units. Coloration in sand barrels, that I did more precisely, actually. Then I was a little bit smarter. And, but I found there that the most prevailing color, actually it's good it came, it was a white with yellow hue. The second was, I would say it was a beige. It's a grayish beige color. And next one is 10%. Is there a grayish and dark brown color? And here I noticed that some of the bone assemblages were sooty, buried with charcoal and fire debris, but a lot of burials were also clean bones. Fragmentation, I show you this, just this drawing. Fragment size declines with time, and actually it's not only me who found it. Also in Sweden, it's known that in early Iron Age, the bone fragments in cremations are much bigger than in late Iron Age. And two main differences are actually that in late Iron Age graves, the spongy parts are very rarely found. Also the child cremations. But in earlier graves, the children are better represented among cremation burials. And sand barrows are, in my opinion, there the children and adults were treated in the same way during the death, if the death happened. And the percentage of determined bone units, of course, is also a good indicator of fragmentation. In earlier graves, it shows better. And there are conclusions. Late Iron Age fragmentation is high. Cremation of children are rare, and most remain sooty. And in graves of the culture of long barrows, less fragmentation. Cremation of children are very common, and varied burial practices is used. And usually one nuclear family or household used one cemetery in western and also in southeastern Estonia. Thank you.
Thank you. Again, we can start questions and discussion. We'll have some time. Any questions? Yes?
About this dating of the cremated bones and the coloring, did you use the color as an indicator of which samples you put for the dating process? I know that these dates have been done in our laboratory, but I don't now remember the color of the bones. Just want to. Did you think about that in the selection process?
Yes, I did actually, because in my opinion, the cremation, when the corpse is cremated in lower temperature, there is some difference probably in the dating.
Good, yeah, that's
values.
Great, because that's exactly that it has to be burnt in the higher enough temperature. That, it's okay. Yeah, great.
More questions? So great. I would just even thank you if you would leave for a moment your last slide for a while with conclusions. I think here is something like ready-made, some answers for archaeologists who are working with periods of cremation. So this is potential of bioarchaeology that we can propose, or at least this could be the basis for further discussion. Thank you, Riley. So we will continue with Ugrophinic part, and now Kati Salo.
Okay.
All right, I want to thank you for inviting me here because we don't have many or almost any bioarchaeologists in Helsinki. So I'm really happy to have been listening here to lectures and also giving my own presentation. Which is about paleopathology of 9 cemeteries in southern Finland. And I'm going to present you taphonomy and also, if I have time, I hope I have time, some problematic case studies in the end, 3 of them. But here are my sites. They are mainly in southern Finland, and they date from the 12th to 19th century. Although I must say that 18th and 17th century is the most usual date for these. But for example, in the end of Iron Age and in the beginning of medieval period, there are 2 cemeteries, which are Hollola and Mikkeli. And I have also in my study, I have coastal towns and inland parishes, which I want to say in the beginning. I want to say my conclusions that they won't get unsaid if I run out of time. And also it might be easier for you to follow the presentation. So one of my main conclusions will be that in coastal towns and inland parishes there has been or in coastal towns there has been more dental pathologies than in inland parishes. No, the other way around. I'm sorry. That in the coast they have been more healthy in dental pathology. And also from other studies I know that there has been the bone mineral content, or the bones are stronger in the coastal towns than the inland parishes, measured by PQCT. And if you were in a paleopathology conference in 2011, I presented the results there. But now I'm going to the, which I'm really proud and happy, because these are made by software that has been made by my husband. So these have been combined different, or this is for example 336 skeletons which have been combined, and the more darker the picture is, the more this skeletal part is preserved. So you can see, for example, that the pubic symphysis is not very well preserved, as well as the sternum is not very well preserved, and some other parts as well. And yes, but I'll go on now. And I can also compare different age classes of the individuals. And if you can, we know that senile adults, they preserve worse than the young adults. And now we can see which parts are the ones that preserve less. It's, for example, vertebra seems brighter here. And also like the neck of the femur, which are known sites for osteoporosis, for example. So it's no wonder that they have been preserved less. And also I can compare female and male preservation and see what's the differences. And I can see a little lighter color here also in the distal radius and ulna, which is than in the male skeleton, which is also a site for osteoporotic fractures. And osteoporosis is more common in men. Why do I confuse everything? It's of course more common in older females than younger and males. And here are the paleodemographic data. I presented this as a percent that you will see the clear difference in one site, which is Hamina. And most of the individuals from Hamina site, there is like a little bit over 30 individuals that are under 6 years of age. And then there are 4 young adult males. So it's clearly different than all the other sites. And then I start with dental pathologies because this gave me the most interesting results. And I'm only showing the ones that show statistical significance. And I have taken into statistic model, I have taken age and sex into account when I have compared the sites. And here you can see that, of course, as usual, females have more caries than males. And here you can see that the individuals in different adult age classes seem to have, or actually young adults seem to have more caries than older people. And here you can see, I will just show you this quickly. Here you can see Renko and Lappeenranta, which are in inland sites, and they have more caries, seem to have more caries. But now when I take into account the number of teeth, which here is young adults, middle adults and old adults. So the number of teeth decreases, of course. And when I take into account the true prevalence rates of caries, so now it shows that actually it goes as it's supposed to be, that young adults have less and middle adults have more and older adults have the most. And then we go to the antemortem tooth loss because this is related to caries. And also here we can see, as expected, that females have more and males have less, and it grows again with age. And here the sites, especially Lappeenranta, has a lot of antemortem tooth loss, and it's an inland site. And here it shows that when I take into account the true prevalence rates, then Pälkäne shows, and it's also an inland site. So there must be something in here going on. And calculus, it's actually we will now skip calculus and also the true prevalence rates, but females seem to have more also. But we go to abscesses, dental abscesses, and females again have a little bit more, and it grows with age nicely. And here the sites that can be seen is Lappeenranta again and Pälkäne. And these are inland sites, and this is the true prevalence rate. And we will skip this one also, so we have time to go a little bit to trauma. And as usual, trauma is found a little bit more on males than females, and it grows steadily with age. And there was some differences between sites. For example, Renko seems to have quite a lot of trauma, but it's mainly agricultural area, and agriculture is known today as one of the most professions that are most traumatic, or traumatic, I mean, have most fractures. And then joint disease also nicely grows with age as expected, and there are some differences between sites. For example, Lappeenranta seems to have a little bit more, and Porvoo, which is a coastal town. I haven't figured out any explanation for this, why there is differences, so I'm open to all suggestions. And also here is a vertebral joint disease, and it grows with age as expected. And here are also some sites which I cannot explain why there are differences. It seems to be most common in Hollola, which is actually end of Iron Age and beginning of medieval period, and I have no idea why. And then also small nodes, I will maybe have time to go through, and actually these were as common in females and males, and usually they are found more in males. So I'm just suggesting that it might be that because usually in archaeology they are related to activities, so it might be that women in the north have been also active as males, but yeah, we'll see what you say. And Pälkäne seems to have most small nodes as well. And here are the true prevalence rates. I've calculated this as taken into account all the preserved lumbar and thoracic vertebra, although it's mostly found in the 11th thoracic vertebra. But still I've done this. But also it shows that Pälkäne, Hollola and Mikkeli, which are the two Iron Age sites, and one historical site inland Paris, which show most of the lesions. And there is also different age classes like young adults, major adults and seniles, but they didn't show any statistically significant difference between the age classes, and so it doesn't seem to grow with adult age. It begins in juvenile age, but then it's steady. And here I have just summed this up. So males have more trauma as expected, and females have more dental diseases, and small node and joint disease is found in both equally. And age progressive diseases were the dental diseases and joint diseases as expected, and cribraorbithelia and hypoplasia, enamel hypoplasia, they are known to be stress indicators, possibly contributing to death, so they were found more in the younger individuals. And small nodes, I have no idea why they are not age-related at all, or doesn't seem to be. Okay, and this is the last slide of the summary. Dental disease seemed to increase in time, so the Iron Age sites have less, and then the historical, but this is known from all around the world that it increases. But what I didn't expect was that dental diseases are more common in coastal towns than inland Parises. I don't know if it's because of the diet, if they have eaten more fish, for example, in the coast, if they have had better hygiene, dental hygiene. This is a toothbrush from Porvoo site, which is a coastal town where we excavated. If it has to do with the fluoride in the ground, because Porvoo area, for example, it's Rapakivi granite, the bedrock. So it could be that there is there is actually more fluor in the drinking water of that area. So it could be that, or it could be genetical reasons also, or some other reasons. But now I have, if I have time, do I have time? Yes, okay, yes. So now I have the most interesting things which I have found. This is from Turku Juli inside, an individual with paper-thin skull and kind of porosis, or what should I call it, in the outer surface of the skull, extracranial surface of the skull. And I have no idea what could have caused this. And here is another picture where you can see actually that it is paper thin. And you can see from the facial bones that it's an adult, so it's not the children. And usually porotic hyperostosis, it increases the size of the skull and not decrease, as in this case. So, but I will show the other. So let's call this individual 1, and then let's call this individual 2, where there is all these strange things going on. It seems that the distal part of ulna is somehow reduced. I don't know why. Also, there seems to be a possible fracture in the neck of the humerus. Also, axis has lost, the dense axis has been lost, and there is a lot of arthritis going on, and also spondylolysis. These are all in the same individual. And then we have also like trauma in the costa and some calcification of the costa as well, and here are some more trauma in the costa, and also possible trauma or in the vertebra of this individual. So these are all in the same individual, and let's call this individual 2. And then I have third individual, which is a child, and here you can see, or maybe can see, but I can tell you that the vomer bone is in 2 parts. It hasn't united. And the same individual, have also, in the vertebra, there is something grown beside it also. So this is the third individual, the child. Let's call it child. And I want to thank you for your attention. And then I will want to, because me and, for example, Markku is organizing the Nordic conference on the application of scientific methods in archaeology in the University of Helsinki next year. And I have preliminary topics, and these include isotopes, osteology, paleopathology, ancient DNA, paleodemography, and you can see the deadlines of the abstracts already here. But I will, when we get the first circle finalized, then I will send all of you. So please welcome to Helsinki as well. And
thank you. So eventually, so much questions there should be and discussion. Well, maybe we will just let's make it short, not to make shorter life for our hosts.
I was just interested in hearing if you look for any chronic infectious diseases in your material. Or
yes, I have few cases. I have a treponemal disease from Turku, which is 16th to 17th century, Turku. I think it's the first. And then I have some possible cases of tuberculosis, but leprosy I haven't found. But if you can see, if you look at my taphonomy pictures, it shows that the distal phalanx are rarely found. or rarely preserved. So it could be that, or it could be that because there are known leprosaries in Finland, for example, Seili Island, so they could be sent there also. So, and one thing I still want to say is that Kerttu Majander, who is studying in the University of Tübingen, she has taken samples of more than 20, I think it was about 30 individuals that I have some belief that they have infectious disease. So she has taken into ancient DNA laboratory in Tübingen, and she will test this for pathogen DNA. So this is really nice that it's happening. I hope somebody will do the isotopes as well. I'm not looking at Markku, or I'm actually looking at Markku and hoping that we will find money.
Thank you, Kati. So I think these your three cases of quiz, we will find that the time to discuss with you just personally, because it seems that time is a little bit pressing. So I would like to invite Peter Tarp to let's switch to another topic, maybe sometimes more traditional one, about cranial measurements.
Thank you. My name is Peter Tarp. I'm going to talk about cranial morphology in Western Denmark. This project is a small part of an Interreg project funded by the EU. The project is about migration and people moving in and out of between the borders, across the border of Denmark and Germany. The larger part of this project is chemical. It's a project called Chemical Life History. Chemists are trying to see migration through time and for each individual. But this cranial-metrics is just a small part of it. I looked at only the frontal bone of the skull, mainly because it's well preserved, fairly well preserved at least, often. And it is known in the literature to show morphological differences. I looked at seven. I took 7 measurements, 3 on these 3, one just by the outside of the orbits, and the minimum width and the maximum width. And these took the chord between the nasion and the brecma point, and the frontal arc measured just as an arc instead of the chord. The difference between these two measurements shows the curvature of the frontal bone. And in the midpoint of this frontal arc, it took measurements from nasion and brecma to see whether this curvature was placed, the main part of this curvature was placed in the lower and the upper part of the frontal bone. I looked at skeletons from almost all parts of Western Denmark that we have skeletons, skeletal remains from. Please pay attention to this number 10. It's a small island just south of Funen, and this number 11 is the city of Schleswig. It's today in Germany, but 150 years ago it's part of Denmark. Today the Danish-German border is around here. So, yeah, this is Jutland. But this is the island of Funen. So from Jutland, I looked at these cities. In most of these cities, there are more than one cemetery represented here. They are all parish cemeteries, except for this one, a monastery, whereas it's both. It's also a parish cemetery, but we also have burials from monks and other holy people. And from Funen, we have these two cities, Odense and Svendborg, and then this Ærø, this is a small island. In all, almost 600 male skeletons. I also looked at female skeletons. I measured female skeletons, but I haven't looked into that yet. In total, I have examined around 900 skeletons so far. And this is what comes out of all these measurements. So you can look, especially this one. This was this small island, Ærø, only 12 individuals. What's interesting with this one is that this is not a cemetery for normal people. This is a private cemetery for a rich family. So all these are males, and they are probably related. Everyone. So they seem to be the odd ones out, at least in this study. So if you try to forget about these ones, you can see there's a group up here that seem to be fairly alike. And we have a few ones that differs a bit, and then there are these three ones that differs some more. But these 5 cities, take a look again at the map. It's this one called Aalborg and Aarhus. It's Slesvig and it's Odense. And what's interesting here is that these are by far the 5 largest cities. There's also this on this number 6 called Horsens. It's not that the largest city, but the other ones are actually the big cities, and has been for this period that I looked at. So this could indicate that these the males that I looked at, that they seem to be more that in the large city people look almost the same over the country, instead of having a kind of a gradient going with larger or more whatever some kind of special mark heads in one end of the country going to the other end. So it seems that people move for longer distances. At least males move not only to the nearby big city, but they actually could move all around the country. And that's a bit. It's not the same result that most of these studies I've read about. They seem to do. But that's what this material shows, at least. So Schleswig, this city down here, this today German city, there are 5 cemeteries from this city that I looked at. two of them are both parish and monastery cemeteries. The rest is normal parish cemeteries. We take a look into this city. This is the medieval Schleswig. We have one outside of the city walls, and there's one on this this island. This is the center with the cathedral over here. We have this St. Clemens, that's the one that's up here, and then this Johannes, it's this one over here. And then the Dominican cemetery in the center. And this is what we get from looking at these cemeteries. We have two that are fairly alike, almost alike. And there are two here, the Dominican, this Rathausmarkt, that look fairly alike as well. And we have the Johannes, the one that's over here, that seem to differ from the rest. This is going a bit deeper into the details about how they differ, these individuals. And we see that Dominican, this one here, seem to be larger than the rest. The horizontal form, it's St. Nikolai there that shows they seem to be wider in the horizontal form. It almost shows the same. But going then deeper into just this one, this Dominican cemetery, we have burials from the east cloister walk in the monastery. We have from the courtyard, and we have from this layman cemetery. And looking at this, it's just a mixture of a lot of different places, and there seems to be no real correlation between, if you can distinguish where people are buried. But as I said, this was the major part of this project was chemistry. So the chemists, they looked at magnesium and barium and strontium ratios in the bones. And if you take these results that they came up with and put this into this one, unfortunately, they only looked at about half of these skeletons, or they measured half of these skeletons, and analyzed them. We get this result. And what you see here is that all of these, this one that seems to be somewhat alike, they are buried in the east cloister, and then this one in the courtyard. Means they are probably the monks or the somewhat religious people at least. And then down here we have this people buried in the cemetery, and there's just one that's popped down underneath this line. So looking at the morphology and taking into account where people have lived and where they, with these isotopes, we can distinguish where people are buried between the different places of the cemetery. So, just to sum up, it seems that males in Denmark, they moved not to the nearby big city, but they moved for a longer distance to any big city. And we can place people in different parts of the cemeteries. Thank you.
Thank you. And thank you for saving some time for discussion. Will there be some questions?
Thank you for a nice presentation. My question is if you have encountered any problems working with craniometrics and measuring cranial form the way you do, because given the European history of using cranial form measurements for various reasons and political reasons, it's a bit sensitive in some ways.
Yeah, it is. This is the first time I presented in a larger forum. As I say, this is not, I'm a PhD student now, this is not my project. I wouldn't like to do this project as a PhD study, but we got some money from the EU to make this Interreg project about people moving and in and out or across the border in this region between Denmark and Germany. And we thought that this would be one of the ways to see if we could detect some differences. But I know it's a bit hot topic, and it's problematic. Yeah.
So some more questions, suggestions?
Hello, my question is that a very nice project you got, but did you also include some dental features?
No. We hoped that we would get some extra money to prolong the project, and actually that part would be looking at teeth, but we didn't get the money.
Well, just thank you for demonstration.
Just one more suggestion, it would also maybe be worth it to look at the form of this frontal sinus, because that also seems to be related, like within families it seems to be.
But it's a far more complicated project. It takes time to do all the x-rays, and it goes beyond this.
Yeah, to take x-rays of 900 skulls, so finally it's another project.
Yeah.
Well, thank you. Well, just by demonstrating that the good old osteoma morphometry sometimes anyway could produce some meaningful and interpretable results. Still can be, it should not be marginalized. Thank you. So, and the last presentation for this morning. Sorry? Yeah. So it will be Aili Marnica from a Museum of Natural History of Latvia. So how bioarchaeological things are presented in museum?
Būs ērtāk, redzēšu prezentācijā. So Aili Marnica will talk in Latvian, but I will translate for you in English. Okay. Aili just told that she was afraid to talk in English because she thinks that her English is so bad that you might kill her. She really said that she's afraid that you all might kill her. That's why she will talk in Latvian and and stay in safety.
Cilvēkus interesē.
So this is the second day when we are listening for very interesting presentations of very serious and scientific researchers. But the question arises, do we do this all only for our self-interest, or is it interesting for other people too? So Aili here is the one who has this connection with wider public, with people who might be interested in popular scientific side of bioarchaeological research.
Un tas ceļš, kā savienot jūsu pētījumus un plašas publikas intereses, ir muzejs.
Of course, the museum is this important link between scientific research and public.
Un mūsu muzejs rāda ne tikai vienkārši dabu, ne tikai dzīvniekus un augus, bet rāda tiešām no pašiem sākumiem, no dzīvības izcelšanas un līdz mūsdienu cilvēkam.
The Natural History Museum shows not only like just some parts of natural just some differentiated parts for nature, but this exhibition is built for illustrating really this evolutionary nature of living organisms, starting from the very beginning and until the modern human.
Šiem senākiem periodiem veltīta mūsu paleontoloģijas ekspozīcijā.
For the earliest times, we have paleontology exhibition.
Protams, ka ir ekspozīcija arī veltīta cilvēka evolūcijai.
Exhibition for human evolution.
Bet mēs tā padomājam, ja mēs rādām cilvēka evolūciju kā tādu, kāpēc mēs nevaram parādīt arī kaut ko saistītu ar seniem latviešiem.
And of course, if there is this representation of human evolution, why shouldn't there be a representation of Latvian material from Latvian archaeological excavations?
Un tā pirms 30 gadiem mēs pamēģinājām izveidot pirmo ekspozīciju, kurā parādījām, kā attīstījās vietējie iedzīvotāji.
Therefore, 30 years ago, museum built exhibition to show the probable evolution of people living in Latvian territory during prehistoric times.
Un, protams, šajā ekspozīcijā mēs nevarējām iztikt bez Latvijas Vēstures institūta antropologiem.
And therefore, of course, collaboration with anthropologists from Latvian History from Institute of Latvian History was necessary.
Tajā bija parādīti gan dažādi galvaskausi. Jūs redzēt, ka šeit pagaidām nav precīza datējuma.
Here you can see some of the skulls that were exhibited. Of course, the dating is not exact. It's archaeological, I believe.
Yeah,
it's archaeological dating.
Mēs parādījām morfoloģiskus tipus, kā varēja izskatīties šie cilvēki.
Probable morphological types and how these people might look like.
Un visa tā ekspozīcija bija balstīta uz Reisas Deņusavas pētījumiem.
This exhibition was based on researches of anthropologist Reisa Deņusava.
Diemžēl tā kā platība, kura bija izveidota ekspozīcija, bija ļoti maza, daudz mēs tur neko nevarējām parādīt.
Unfortunately, this first exhibition was on a small scale because there was just no space for a bigger exhibition.
Tomēr zinātnē iet uz priekšu, un mums paveicas, ka mēs dabujam arī lieku platību un sākam veidot jaunu ekspozīciju.
Here you can see that in the late 90s, the new wider exhibition they started to build.
Un šajā ekspozīcijā mēs izmantojam jau ne tikai antropologu pētījumu rezultātus, bet arī vairākus citus pētījumus, kas bija saistītas gan ar paleobotāniku un paleozooloģiju.
And you can see that this new exhibition was based not only on anthropological material, but also paleobotanical and paleozoological too.
Tas ir ļoti svarīgi, jo cilvēku nevar izraut no dabas. Un viss, kas notiek ar cilvēku, ir cieši saistīts ar to, kādas izmaiņas notiek dabā.
Of course, it's due to the fact that human life is deeply rooted and deeply connected with changes of climate.
Un šeit šajā slaidā ir piemērs, ja palinologu pētījumu rezultāti izskatās, kā tādas pelēkas neizteiksmīgas diagrammas, tad mēs tos parādījam jau kā herbārijus un kā it kā dzīvas dabas gabaliņos, kas atbilst katram klimatiskam periodam un rāda, kā mainījies klimats un kā mainījies tā vide, kurā dzīvoja cilvēki.
This is a very good example how to represent scientific results for the wider public. As you can see, this pollen analysis might not be interesting for public, but in museum exhibition you have a herbarium, and that illustrates this scientific research and findings.
Mums ir vairāki interesanti eksponāti, kas pierāda, kādi dzīvnieki pirmie atnākuši, ka tiešām tajā laikā jau šeit bija arī cilvēki, mednieki, kuri nogalinājuši šos dzīvniekus.
Of course, proofs that first animals, that one of the first animals in Latvian territory was reindeer, and that humans followed them.
Kā dzīvojuši daži dzīvnieki, kuri bija iecienīts medījumu objekts, bet mūsdienas jau šeit nav sastopami.
One example of animal who was in history and prehistory were living here in Latvia, but not anymore in nowadays.
Un tas bija tas pirmais rezultāts vitrīna, kurā parādīts pilnīgi viss paša augšā sīkiem cipariņiem, kurus jūs pat nevarat pašlaik saskatīt gadu tūkstoši pirms Kristus, pēc tam uz tam plāksnēm klimatiskie periodi ar visādām izmaiņām augu valsti, tā pelēka josla Baltijas jūras attīstības periodi.
And here you can see all these different results put together in one visual representation. Herbarium, different stages of Baltic Sea, flora and fauna changes in Latvian territory, all combined together.
Un visšaurākā svītriņa, kas tur ir starp jūru un kultūram, ir arheoloģiskā periodizācija. Mēs varam ne tikai izsekot dabas izmaiņām, bet kā arheoloģiskie periodi, kādas attiecības arheoloģiskie periodi ir ar visam dabas izmaiņām.
And in between you see this straight gray line. There is archaeological periodization represented, and also it's so you can see how it represents together with climatic changes.
Un saglabājam visus galvaskausus, kas bija pirmajā ekspozīcijā, kā piemērs kultūram palika vairāki priekšmeti no Annas Dariņas, Franza Zagorska un Ilzas Lozes kolekcijām.
From the first exhibition, all prehistoric skulls were incorporated in this new exhibition. Also, archaeological items and reconstructions of inhabitants.
Uz šīs vitrīnas piemēra mēs varam stāstīt gan par dažādiem morfoloģiskiem tipiem, gan par dažādām tradīcijām, un viens no galvaskausiem šis, par kuru stāstīja šodien Ilga Zagorska no kolektīva apbēdījuma, kur ir ļoti dāsni izmantots okers.
By the way, here you can see this one skull is from Zvejnieki, from common burial, about which archaeologist Ilga Zagorska was talking today.
Atpakaļ? Šis.
Yes, that's this skull from this burial, which was with a lot of ochre.
Un tagad jau ir tie paši galvaskausi, precīzi datēti.
And here you can see that now we already have some radiocarbon dates for these skulls.
Šajā ekspozīcijā mēs parādījām jau ne tikai cilvēkus, bet arī visu, kas bija viņiem apkārt, ko cilvēki medījuši, ko viņi zvejojuši.
And this part of exhibition represents okay, this part of exhibition represents one of the main part of everyday human life. As you can see, it's about hunting and fishing practices.
Un tieši mūsu muzejā glabājas Ilzes Lozes savāktā paleoihtiofaunas kolekcijā, kuru arī vēl var pētīt. Tad tas viss ir priekšā, ja kādam ir interese par šo tēmu.
And in Natural History Museum also is paleoichthyological material from Lubāna Valley.
Un šeit ir daži skati no pirmās zāles, un šeit ir arī otrā zāle, un otrā zāle pārstāvētie materiāli, kas ir mūsu klātesošo zinātnieku pētījumu rezultāti, tai skaitā arī viņu uzticēšanas paraugs, jo materiāli mums bija iedoti ekspozīcijai vēl pirms bija aizstāvētas doktora disertācijas. Tātad šeit ir Gunta Gerharda materiāls un šai vitrīnai, kur ir cilvēka auguma izmaiņas, mēs varam stāstīt arī par mazo klimatisko periodu un par to, kā mainījās cilvēku saimniecība, jo pēc rasiņa datiem varējam sastādīt tādu tabulu, ko cilvēki audzējuši.
For example, here is a visual representation of
Tā kā ir laika limits, turpmāk tulkojuma nebūs, es tikai ļoti ātri parādīšu dažus kadrus.
Okay, so because time is limited, you will just see some.
Gunitas Zariņas materiāls. Saglabājas vairākas kartes. Un, protams, kā mēs rādām, kādi cilvēki dzīvojuši arī Rīgas teritorijā. Un kā šie cilvēki, kas dzīvoja Latvijas teritorijā, atšķiras vai tieši otrādi ir līdzīgi ar kaimiņu valstu teritoriju iedzīvotājiem. Tomēr arī pēdējos gados viss neapstājas, strādā visi, gan geologi, gan palinologi, gan antropologi, un mēs regulāri ievedam dažādas izmaiņas tajā ekspozīcijā, un tagad jūs redzat, ka šeit tā karte vitrīna izskatās jau daudz bagatīgā, un šeit mēs parādījām arī Aleroda ģeoloģisko posmu, kad klimats uz īsu laiku kļuva ļoti, ļoti silts. Un tā kā tik maza ekspozīcija nevar parādīt pilnīgi visu, mēs regulāri rīkojam izstādes, kas ir veltītas atsevišķiem reģioniem. Šeit ir izstāde par ēmieļiem, par akmens laikmetā apmetnieku Lubana plānos, arī Rēzekne bija atsevišķa izstāde, un, protams, nevarējam arī iztikt bez Stārnates. Stārnate bija veltīta gan īpaša konference, gan izstāde, kur parādīti arī Valda Bērziņa pētījumu rezultāti, un pēdējais Ilgas Zavorskas materiāls par ziemeļbriežiem. Un, protams, ka dažādi pasākumi, kuros stāstam jau par sīkam detaļam, gan par dietam, gan par to, kādi īpaši apstākļi bija svarīgi cilvēkiem. Un tā, ka mēs strādājam ne tikai muzejā, bet arī ārpus muzejā, to visu darbu mēs tiešām nesam ļoti plašā auditorijā. Un es to jūtu, ka visi tie jautājumi, kuri šodien un vakar izskanēja jūsu referātos, tiešām cilvēkus interesē gan par patoloģiem, gan par zobiem, gan par visu, ko jūs stāstījāt.
As you could see, Natural History Museum of Latvia works with a wide public, even outside of the museum. And Ali Marnica is the one who can tell you for sure that public is interested in all these interesting research topics that we all are investigating.
No muzeja valodas barjeras nebūs
By the way, in this museum, there will not be problems with language because they have audio guide in several languages. Is there any questions?
Baltijas, thank you. I think we could discuss many things about this last presentation during lunchtime, and maybe organizers have some housekeeping issues.
After the lunch, we have only one session. We have some changes. And this session possibly will be until 4 o'clock. And then we are invited to go to Museum of History of Latvia to see a very, very nice exhibition about amber. It is next step to today. Okay? And in this time, it's lunchtime. Please enjoy.